In this lesson, we'll be looking at interquartile range and semi-quartile range. Recall from one of our previous classes where we talked about quartile. We said that when a given set of data is divided into four equal halves, or equal division rather, we call it a quartile, such that we have what we call the first quartile Q1, the second quartile, which is also known as the median. And we also have the third quartile, which is known as the upper quartile. And then the fourth quartile Q4, which is the whole of the set of data. So Q1, Q2, Q3, and Q4, when a given set of data is divided into four equal divisions, this Q1 is called the lower quartile. Lower quartile, let me call it. Q2 is median, Q3 is upper quartile, and Q4 is the 100% or the whole of the data. So interquartile range, remember range is the difference between the highest and the lowest within a given data set. So now we are talking about interquartile range here. So interquartile range therefore will be the difference between the upper quartile Q3 minus the lower quartile Q1. Why semi-interquartile range? Semi is when you divide something into two. Will be this divided by 2. That is just the meaning of interquartile range and semi-interquartile range. Interquartile range is the difference between the upper quartile and the lower quartile. Why semi-interquartile range? If the difference between the upper and the lower quartile divided by 2. Now, how do we find that from a given data? Example 7 yesterday, discussed below for a group of 24 students in a biology test. Calculate for the distribution, the range, the interquartile range, the semi-interquartile range. For an ungrouped data like this, we need to arrange the data in order of size, either ascending or descending. So in this case, I'm going to arrange the data in ascending order, starting from the least to the highest. So the least score here, looking at this, should be 10. Let's start with 10. How many 10 do I have there? 1, 2, 3. I think there are 3 10 there. So 10, 10, and 10. The next score there is 12. How many 12 do I have? 1, 2, 3, 4, 5, 6. Oh, no. This is not 12. That is 22. Let me count again. 1, 2, 3, 4, 5. 12. There are 5 there. I have 12, 12, 12, 12, 1, 2, 3, 4, and 12 again, 5 of them. The next one is 14. How many 14 do we have there? 1, 2, 3, 4, only 4 of them. 14, 14, 14, and 14. 1, 2, 3, 4. And the next is 15. How many 15 do we have? 1, 2, 3, only 3 of them. 15, 15, 15. The next is, we have 16. No. So the next is 17. 1, 2, only 2 of them. 17, 17. The next is 19. 19 is only 1. There's no 19 there. No 19 there. Okay, so only 1 of it. The next is 22 or so. Oh, we have 20 here, which is only 1, 20. And the next is, do we have 21? No. So the next is 22. How many 22? 1, 2, and 3. Hope I did not omit anyone. 22 again, and 22 again. Then finally, we have 26. Okay, there's another 22 here. That means there are 4 of them. Then we have 26. How many of them? Only 1. 26. Now, since we are talking about interquartile range here, okay, first of all, let's calculate the range. That is question A. Range is the difference between the highest, which is 26, and the lowest, which is 10. So 26 minus 10 is 16. Now for the interquartile range, for an ungrouped data like this, these scattered items, we need to divide this item into 4 equal divisions. By the way, how many items do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. 24 divided by 4 is 6, meaning in each quarter we will have 6 items. So we will count 6 for the first quarter or the first quarter. Let me call it quarter, not quarter yet. The first quarter, that is, I'm dividing the item now into, I will count, since 24, I have a total of 24 items here. That 24 divided by 4 is 6. So I will have, count 6, 1, 2, 3, 4, 5, 6. So I have 10, 10, 10, 12, 12, and 12. For the first quarter, 1, 2, 3, 4, 5, 6. So my first quarter stop here. The second quarter we start here, which is 12, 12 again, 14, 14, 14. How many do I have now? 1, 2, 3, 4, 5. Remain 1. 1, 2, 3, 4, 5. So we are going to stop it there. 1, 2, 3, 4, 5, 6, and 14. The next quarter, that is the third one. The third quarter will be, we start here now. 1, 2, 3, 4, 5, 6. Divide it there. So I have 15, 15, 15, 17, 17, and 19. And finally, the fourth quarter will be the remaining data, which is 1, 2, 3, 4, 5, 6. So 20, 22, 22, 22, 22, 1, 2, 3, 4, 1, 2, 3, 4, and then 26. So this is the fourth quarter. So remember the B part, so we should calculate the interquartile range. Interquartile range is equal to Q3 minus Q1. The question then is, where does Q3 lie and where does Q1 lie? Q3 is here, and then Q1 is here. So the difference between the item here and the item here, that is the highest value here, which is 19, and the highest value here, which is 12, will give us the interquartile range. So given that the highest item here 19 and the highest here is 12, 19 minus 12 is 7. So the interquartile range is 7. The semi-interquartile range is the interquartile range divided by 2. Semi-interquartile range is equal to Q3 minus Q1 divided by 2. Q3 minus Q1 is already here, which is 7. So 7 divided by 2, 3.5. So the interquartile range is 3.5. Okay, in this example 8, we are going to learn how to find the range, the interquartile range and the semi-interquartile range from a grouped data or a grouped distribution like this. The questions in the table below shows the distribution of scores obtained by applicants in a written examination. So you can see here we don't have a definite score. Rather, the scores are given in a range of 20 to 29, 30 to 39, and all of that. The question then says, estimate from the scores the range, the interquartile range, the semi-interquartile range. Let's do that right away. For the first question, which is range, we know that range is the difference between the highest score and the lowest score. The highest score here is 89. That will be 89 minus the lowest score is 20. 89 minus 20 is 69. Then to get the interquartile range and the semi-interquartile range, we need to prepare a table. Remember that the interquartile range is the difference between the upper quartile Q3 and the lower quartile Q1. The question then is, how do we find Q3 and how do we find Q1? If you have taken the previous lesson on quartile generally, then we said that when a distribution is divided into 4 equal divisions, what we have is a quartile. So we have Q1, Q2, Q3, and Q1 usually is L1 plus N divided by 4 minus FB divided by F, and then multiplied by C. What is L1? What is N? What is FB? What is F? And what is C? L1 is the lower class boundary of the quartile in question. In this case, the first quartile, or the lower quartile, rather, not the first quartile. The lower quartile, which is Q1 here. Then N is the total cumulative frequency. FB is the cumulative frequency before the quartile in question. In this case, the lower quartile. F is the frequency of the quartile, and C is the class width. So all of these, for example, L, FB, F, and C, they are not in this table here. So we need to prepare a table that will reflect all of these items. How do we do that? For the table here, we are giving class interval. From that class interval, we need to get class boundaries because L is the lower class boundary of the quartile. And the class boundary for 20 to 29 is, remember, to form a class boundary, you decrease this first number by 0.5. So 19.5 will be the lower class boundary for that instead of 20. So let me call class boundary for the ages. Let me put ages, then in bracket the class boundary for those ages. And I need the frequency. I also need the cumulative frequency. The class boundary here, instead of 20 to 29, 20 to 29 is class interval. So the class boundary is 19.5. 29.5. Let me put line to avoid confusion. The next one will be 29.5 to 39.5. The next will be 39.5 to 49.5. The next will be 49.5 to 59.5. 49.5 to 59.5. The next is 59.5 to 69.5. Then we'll have 69.5 to 79.5. 79.5. Finally, 79.5 to 89.5. Okay, we'll put line to separate them so that we don't get confused when trying to pick the frequency and the cumulative frequency. So what is the frequency of the first? We have 10, we have 7, we have 3, 12. Next is 693, 6, 9, and 3. And the cumulative for the first one is still remain as 10, 10 plus 0. Then 7 plus 10 is 17. 3 plus, what was here? 3, 3. What is blocking it? Yes, it's 3. How come it's not appearing one? 3 plus this is 20. 12 plus 20 is 32. 6 plus 32 is 38. 38 plus 9 is 47. And 3 plus 47, 50. So N, capital N, is this number, the last number there. This is our N. Remember, Q is L1 plus N over 4 minus FD over F times C. So we need to know which of the items fall into the lower quartile here. To get that, to get the lower quartile item, we divide that N by 4. Remember, quartile is when you divide a distribution, the total distribution by 4. So the total distribution, or the total cumulative frequency is 50. 50 divided by 4 will give us 12.5 or 12 and a half. 12 and a half item is the lower quartile. So where does that 12 and a half lie? It lies in this 17 here. So this is 10. Anything from 11 or 10.5 upward, or 10.1 upward, or 10.000 something upward, we have to go to the next item. So 12 and a half lies in this, so that L1, which is the lower class boundary of the quartile, in this case the lower quartile, the lower class boundary there is 29. So you trace that 17 to your class boundary, the lower is 29.5. So L1 is 29.5. N over 4 is still here, which is 12 and a half. FB is a cumulative frequency before the quartile. Our quartile lies in the 17th position. What is the cumulative frequency before that position is 10. So FB is 10. FB is 10. Then F is the frequency of the quartile. Our quartile lies in this row here, and the frequency in this row is 7. So F is equal to 7. YC is the class width of the quartile. So the class width for the whole data is the same. 39.5 minus 29.5 is 10. These two is also 10. So the class width for the whole of the distribution are usually the same. So in this case, C is 10. So with that, now we can calculate the lower quartile, which is Q1. Let me create more space. The lower quartile, Q1, Therefore, which is L1 plus n over 4 minus FB divided by F times 10. This formula there, that is what I wrote, will be 29.5 plus n, which is n divided by 4, which is 12 and a half, or 12.4, 0.5 rather, minus FB, FB is 10, divided by F, F is 7, then multiply by 10. That will be 25.9, or can you imagine? 29.5, but I wrote 5.9. Let me correct that to avoid confusion. This is supposed to be 29.5, 29.5 plus 12.5 minus 10 is 2.5, divided by 7, multiplied by 10. That will be 29.5 plus 2.5 times 10 is 25 rather. And 25 divided by 7 is 3.6. So I have 29.5 plus 3.6, which gives me 33.1. So my first quartile, or my lower quartile rather, Q1 is 33.1. The next thing we need to get here is the upper quartile, Q3. So how do we get upper quartile? Remember that upper quartile Q3 is equal to L1 plus 3n divided by 4 minus FB over F times C, where L1 is the lower class boundary of the third quartile, FB is the cumulative frequency before the third quartile, F is the frequency of the third quartile, and C is the class width. The question is, how do we locate the position of the third quartile? We get that by 3n divided by 4. 3n, that is 3 times 50, because n is 50, so 3 times 50 divided by 4. 3 times 50 is 150, and 150 divided by 4, I'll be 37 and a half. 37 and a half. So our third quartile, or the upper quartile, lies in the 37th and a half position in the cumulative frequency. How do we locate that? Look at our cumulative frequency. 37 lies in this row here, because before this row, the highest cumulative there is 32, which is far, far below 37. So 37, anything from 33 down to 38 is in this place, meaning our 37 and a half item is in this row. Then the lower class boundary there is 59.5. Therefore, our L1 is 59.5. L1 is 59.5. FB is the cumulative frequency before that row, and the cumulative frequency here is 32, so FB is 32. FB is equal to 32. F is the cumulative frequency of the quartile, the third quartile. Our third quartile is in this row. The frequency there is 6, because F is the frequency of the quartile in question. And then our quartile here is in this row, which is 6. So F is 6. F is equal to 6. C remain constant for the whole of this distribution. The class width is equal. Our class boundary here is 59.5 to 69.5. 69.5 minus 59.5 is 10. So C is equal to 10. Therefore, the third quartile, or the upper quartile, is 59.5 plus 3n, that is 3 times 50 divided by 4 minus FB, which is 32, and divided by F, which is 6, and multiplied by 10. That will be 59.5 plus, remember that this times this divided by this give us 37.5. That is 37.5 minus 32, and divided by this 6 here, multiplied by this 10 here. That will give us 59.5 plus 37.5 minus 32 is 5.5. I have 5.5 divided by 6 times 10. 5.5 times 10 is 55. I have 59.5 plus 55 divided by 6. And 55 divided by 6. That should give us 9.2 approximately. So here we have 59.5 plus 9.2, 68.7. So our upper quartile is 68.7. With that information, we can then calculate the interquartile range, which is interquartile range is upper quartile Q3 minus lower quartile Q1. 68.7 minus, what was our lower quartile? 33.1. 33.1. That will be 7 minus 1 is 6, and 8 minus 3 is 5. 6 minus 3 is 3. So our interquartile range is 35.6. And then we also to calculate semi-interquartile range. Semi-interquartile ranges, interquartile range is equal to interquartile range Q3 minus Q1 divided by 2. And Q3 minus Q1 is 35.6. Then divided by 2. 35.6 divided by 2. 35 divided by 2 is 17. Remainder 1. Put the 1 there. That is 16. 16 divided by 2 is 8. So semi-interquartile range is 17.8.